Welcome to the video for C3.16 where we're going to look at the mole. So pause the video and have a go in answering these questions. Okay, so hopefully we've come up with the idea that this represents the biggest of the two numbers, represents the mass number, and we've used our periodic table hopefully to find that for hydrogen this is 1, for sodium is 23, and for chlorine it's 35.5. And that's unusual because it's an average of the two isotopes of chlorine, which are 35 chlorine and 37 chlorine. And if you can't remember your work on isotopes, I suggest you go back and have a look at that. And hopefully you've done this next bit as well. So once we've got that, we can calculate the relative formula mass. So if you remember how to do the relative formula mass, you add up the individual relative atomic masses. So sodium's 23, chlorine's 35.5. So added together, that would be 58.5. And HCl would be 1 plus 35.5 would be 36.5. And again, if you can't remember how to do relative formula mass, look back in your notes because you need to be able to do it. So our learning objectives, I'm not going to read all of that. You can pause the video if you want to read it. So a quick reminder, two numbers in the periodic table. Biggest number is the mass number. That's the one that we are interested in today. So in your periodic table that you use in your exam, it's the other way around here. You have the biggest number at the bottom. So this is the mass number, and that's the one that we're interested in today. So the atomic number we don't need to worry about. So pause the video and have a go at answering this question. So what does a pair, a dozen, and a ream paper have in common? So hopefully we know that a pair means 2, a dozen means 12. We might not know a ream, it's not used as common, but a ream means 500. So all of these are just special words that are given to a specific number. And a mole is the same thing. There's 2 videos here, so if you can watch these 2 videos, that would be really good. The EdTed one quite explains it quite well. Molar Eclipse of the Heart doesn't explain it as well, but it is a great parody song, and it's one of the most absolutely fabulous things on YouTube, so go and watch that. So we've met units of measurement before, so a mole is just a unit of measurement. So it's a unit of measurement, and it tells us how many atoms or molecules they are. So if we have a look at these quantities, we'll notice that they've got something in common. So 7 grams of lithium, which has an atomic mass of 7, and 20 grams of neon, which has an atomic mass of 20, and 39 grams of potassium, which has an atomic mass of 39. So what we find for a mole, so a mole is a certain number of particles, and when we have a mole of those particles, if it's an element, then 1 mole of an element has the same mass as its relative atomic mass. So all of these contain a mole of atoms, and a mole is 6.02 times 10 to the 23, which is a really, really big number. So definition of a mole, so you need to copy this into your notes. A mole is the amount of substance that contains the same number of particles as 12 grams of carbon. So that should be of rather than or. And that's 6.022 times 10 to the 23 particles. So just like relative atomic mass, we're defining it compared to carbon-12. So there's a formula that links the number of moles, the mass, and the relative formula mass. So the number of moles is the mass divided by the relative formula mass. And we can do one of these magic triangles to link these. So you can either learn this formula, so you can write that formula into your book and learn it. If you do the formula version, then you will need to be able to rearrange it. So we've got number of moles is mass over relative formula mass. So if it's a compound, we use relative formula mass. If it's an element, then we'll use relative atomic mass. So we need to be able to rearrange this. So relative formula mass would be the mass over the number of moles. And if I want the mass, that would be the number of moles times by the relative formula mass. So if we don't like rearranging, we can just remember the magic triangle, and then we can just cover up the quantity we want. And then it allows us to work out what the other one is. So a couple of examples here. So if I've got 9 grams of water, how many moles do I have? So number of moles is the mass, and water's a compound, so it's going to be the relative formula mass. So water's H2O. So if we're looking at the periodic table, the biggest number for oxygen is 6. Biggest number for hydrogen is 1, but there's 2 of them because we've got that little 2. So 2 plus 16 equals 18. So the relative formula mass is 18. So the mass is 9 divided by 18, which is going to be 0.5. So there are 0.5 moles in 9 grams of water. Second example, what's the mass of 0.25 moles? So the mass is going to be the number of moles times by the relative formula mass. So although this is a element, because it's a diatomic molecule, we need to use a formula mass. So it's 0.25 times by, so nitrogen, there's 2 of them, and the relative atomic mass of nitrogen is 14, so that's going to be 2 times 14, which is 28. So 0.25 times by 28 is going to be 7 grams. So we'll do some examples. There's a worksheet for you to have a go at. So have a go at the worksheet that's on Microsoft Teams, and then check your answers, which are at the end of that worksheet. So you can stop there if you want, but there's an extension task here. So you're sometimes asked to work out how many moles there are compared on the number of molecules, or the other way around.